Hey, thank you. Let's get started. Agenda today is to review the agents at very concepts, at very high level. Then I'll be talking about the key concept, the autonomy, and then different levels of the agent. Before we start thinking about the design patterns, we need to be aware of, different levels of different types of agents that we are visualizing, and then industry is trying to figure out. And as part of that, I will talk about the design patterns. As you know, agent design pattern is of course a new topic, right? As we are entering into agentic based application design, every one of us are learning, and then eventually it becomes a good design pattern, and then best practices, in the coming years. So today's design pattern is mostly coming out of my experience and few of our colleagues' experience, and then few things taught in the support vectors class, I mean courses. And please do expect, like, this is an evolving field. And then we will then talk about the LangGraph. That is the one of the agentic platform we want to take and then apply these design patterns. Of course, there are, that's the reason I asked the question, I polled the question, what is the platform you guys are familiar? Let me take the poll and see where we are, right? And then, yeah. So if you look at the poll result, yeah, yes, of course, LangGraph and Crew AI in the top. Other things, I don't see AutoGen, but all other things like N8N is kind of a service agent, development or builder and runtime service. And sure, AutoGen is here. Yes, there are OpenAI also here. Nice, So at least we know, Crew AI and LangGraph is leading the pack right now. Thank you for providing that input. And another one, recently there was a conference in LangGraph. I will try to update few things from that. It has a lot of YouTube, and I will point to that. Please feel free to, watch those YouTubes. A lot of good information from there. So essentially, what's going on in a little bit summary here, right? As we are, into that agentic application development, many organization, of course, has a lot of use cases. In my organization, we have many use cases in customer experience. And then we have initially last year, we started developing RAG-based applications for the chatbot, customer service, and then adoption frameworks, renewal. So if you take any domain, there are chatbots and assistants and co-pilots were being developed. And slowly the organizations are wanting to move into agentic application. What that means is, there are some limitations we saw in regular simple LLM apps. And as the complexity grows of any application, we want to tackle the complexity. And agents-based design is one of the approach to think about the complex LLM application into separate, pieces. And then, the agentic-based approach, component-based approach is evolving. It is very similar to what we have seen in traditional. You might have heard about the monolithic application, and then monolithic application, as it grew, it was very difficult to maintain, and then change, even for small changes, makes a big deal, and then it breaks the code. So a lot of those issues in monolithic based application, in that industry went into microservice based applications, right? Microservices based platforms and applications. And then these microservices were able to wire together, right? In many ways. You can imagine this microservices, has a hierarchical wiring and then structured wiring. So many types of messaging between the microservices, and then consolidation of microservices, and then things like that happening in the microservice world. I'm just giving an analogy, right? In our world, in the agentic world, what I want to call it as an LLM app, a little bit of definitions. Right now, when you look at the literature in the internet, sometimes, you come across LLM. They refer the application you are writing as LLM. right? Some of us, we know LLM means the large language model, like OpenAI, ChatGPT, Llama. But in many literature, you might see LLM is actually referring to the application, that that person is developing. So we sometimes used to call RAG. So these are different terminologies used: RAG, LLM app, application. App means application, and then agent. Now we are calling a agent. So those are all sort of software which involves using the large language model, reasoning model, for into some, for some activity. And I'm going to cover what those activities are, and also for finally summarizing and then modeling the language and send the results back. So with that little bit of background, what's AA agent? There are many definitions you can come across. These couple of the definitions, this sets a little bit of a background. By the way, I'm not in video today. Apologies for that. I am sitting in a location where the light is not that powerful. So I'm just on audio. But let me know if you see any difficulties in following me. I can come to the video. Okay, so these are the definitions we see, right? I mean, traditionally, what is agent? Agents are something, it actually perceive the surroundings or environment, right? And get some information, and activators use the activators or sensors. Activators is a type of, you can say, control the environment and then do some task. That's a traditional definition of a agent. One of the example is the, the home robo vacuum cleaner. That is one of the agent, that is a AI agent. It's able to sense that environment as you switch on. It's able to figure out the movement around the home, and then it does perform the task, and then it goes back to that its place after it is done. Well, that's a traditional agents. Now we are applying that to the LLM app. So now, what is AI agents in LLM app? Again, it's a system that uses the LLM for many things. Sometimes it uses the LLM for reasoning and planning, and then sometimes it uses the LLM for actually creating the output, right? Summarizing and as well as formalizing the output. So it uses the LLM for many different needs in the LLM app scenario, or agents. Now we are going to call agents. So essentially, given the context of the problem, a lot of tools at its disposal, the agent does everything it needs to do to make the objective, to able to achieve the objective. So that's a definition, you can see in some places in the agents. But let's talk about what others in the industry, the top guys, actually think about these agents. The reason we want to know from a little bit others as well, folks are thinking differently. Slowly the consensus is coming. What is AA agent means, but let's see what Andrew thinks about that. Andrew thinks, a leading expert, right, defines the agent as autonomous system capable of understanding NLP, natural language. Yeah, obviously it's going to understand our voice as well as text and sometimes video, and learning from their experiences, performing a wide range of tasks on behalf of users. So this is one of the definition from Andrew. All right, and we'll see a few more, couple of more experts' definition. So the key word here, in my opinion, is autonomous system. So agents is considered as autonomous. When you say your application is agents, there is an aspect of autonomous has to be there. So it could vary from one level to low level to high level, but there is, generally the expectation is when you call something in an agentic application, right, we do expect there is an autonomous part of that. And then, further, Andrew says that he says that, instead of arguing about autonomy, when you might have seen in your company, I mean, I have seen in my company, a lot of this initial RAG application, now they call agents. I mean, sometimes I don't agree. It's just a brand name, they're putting around the RAG application is agents. But is it wrong? May or may not. If this RAG application slowly move towards the autonomy in the grade, in the level, then who knows? That can be called as agents. So here again, the summary is, there is no rule here. It says this is what agents autonomy, this is a level of autonomy you need to consider there as an agents. It's a scale. All right. So basically, I want to say is don't fight for it. Aware that there is a grade, there is a level of autonomy you can build in the agents application. And his point is this is more of a guiding principles. He says use the evaluation framework is one of the, though it's not tied to definition, but I'm just pointing out in one of the meeting recently he was pointing this out. So I'm going to share those videos as part of this. But anyway, so he basically the idea is, not many people are thinking about evaluation of the agents, right? His point is, we should start with that. Think about the using the evolve framework as a mean to start thinking about designing. So the way we are going to use this statement is we are going to think about design patterns, for a given problem or use case. When we start thinking about a design pattern, we might start with a simple design pattern which makes sense at that moment. And then as we go evolve, as the complexity or as the user base or as the use case increases, we might switch the design pattern to the better design pattern. And then at that time we need all the evolves, to keep making sure things are working fine as well as improve the evolve. So I just want to introduce that evolve is very key component of. It's like, we used to say testing is a key component for any application. It's the same manner evolve here is the key component. Well, and then single team multi-agent systems are emerging, and agent-to-agent communication between different teams agents is still early. The way I understand this statement from Andrew is that in any given organization, right now your application domain, if you're in finance or customer support, now that after the chatbot era, right, the now agents era, you're still thinking in your domain. Pretty soon, that is what going on right now. But as the time progress, maybe in a year or so, now different domains is going to agents going to come together and talk. Well, yeah, that is going to happen, definitely. You're right. I mean, as you can imagine, in my company now, we are thinking about, we have I won't say hundreds, at least 30, 40 different chatbots are there. At some point, there will be a consolidation of that, or there will be a single chatbot will able to interact with multiple different agents in different domain. We can easily see that is coming. So, but he says it is still in the early development. That's a point. Um, while complex agentic workflow exists, many business opportunities lies in simpler, more linear workflows with occasional branches, such as automating tasks involving web searches. Yeah, that's I think the way I understand. Yes, every organization has a lot of complex workflows, especially across the domains. Exist today. The way you can imagine, right, how the users log into different websites, internal websites, and then perform some task, taking some information from one internal website or document and going to another internal website or even external Salesforce, and then entering the same information. So these are all in silos. So those workflows are going to come together, with the agentic approach. So that's a statement from him. Okay, now let's think about what, by the way, I will stop every 15, 20 minutes, pause, and then ask for any questions. We'll have a couple of pauses before we end it. So now, what about Anthropic, right? Anthropic actually, a little bit, pioneer in defining agents, MCP tools, and things like that. So they are trying to define, as you can read, let me see that. I mean, you can keep reading about this if you don't mind. My point here is my Anthropic. We categorize all these variations as a agentic system, right? But draw an important architectural. Okay, so this is a good insight to me because as we understand agents, then there is a thing called workflow. Workflow is going to be one of the design pattern in agentic design. But think about what is a workflow. That's a crucial understanding we need to be clear about ourselves. Initially, I said autonomy. Now we are probably agreeing that there is a varying level of autonomy where we can build the agents. We talk about what is autonomy. I'll give you an example later on. But workflow is another aspect. Workflow is another aspect of the same thing. Basically, but Anthropic is making a distinction between workflow and agents. Okay, the way you can think about, there is a predefined code path and a dynamic code path. When you have a system that knows the code, when I say code path, execution path, you are asking a question to the system knows I'll go, go to website A and B and C and D and then check and then finally send the results. That's kind of a predefined which website you need to go, which database need to go. It's all predefined. It might choose, if one fails, it might take other ones. Even that is called predefined. Some of those if then else conditions, if it's failed, look for another similar system, backup system. Still, it's called predefined. So those are all called workflows. The traditional RPA industry, robotic process automation, they evolved this for last 20 years, right? Starting from simple Unix shell scripts type of automation. In the RPA industry, created sophisticated tools and monitoring and then workflows to wire different business process in a company. That is called workflow because there you as a when you want to define those business workflow process, you work with experts in those domain. You bring in each domain experts and then define the execution path. Use the commando or so many workflow tools are there, and then you predefine and then make it work and then test it. And since then every business process goes through the same path. It might handle some, as I said, error conditions and choose different path, but pretty much it knows the path which it needs to traverse. But however, in the agentic workflow, I mean, you can call in agents. These workflows doesn't need to be, there is a workflow also in agentic system. It's how you are going to think, as you think in the design. In one of, you can design an agentic system with completely predefined code path. You can design an agentic system with the execution path, code path can be resent dynamically, and then something which is very dynamic. It can be done, both can be done. It's how you choose, what you choose. We are going to say this is a design pattern. So that is a definition from Anthropic. Okay, so far we are clear about autonomy and then workflow and then code path. These three things is will be the basic building blocks which we are going to use it for design, or say for communicating the design patterns. So by the way, so in this keynote conference, please, if you are aware, it is great, but go to this YouTube Interrupt 2025 keynote. It just happened about a month back. There's a lot of wonderful sessions on how companies are using the Lang chain and LangGraph platform. So LangGraph has three platforms. I mean, three, I would say services, right? One is a Lang chain, which you mainly dealing with the simple applications, right? They provide you the SDK to develop, and individuals can develop a simple LLM app using the Lang chain. And then they started thinking about LangGraph, building the agents. You can build agents using the LangGraph. And third component they have is what they have is a runtime, what they call platform container, running this LangGraph agents in a scalable way. So, of course, they started with providing simple SDK and ask you to run. And then, like any other open source, then now they have a scalable platform to run thousands of agents simultaneously, for an enterprise. So why that is important? Just knowing the LangChain or LangGraph is not going to be sufficient, right? You can write a laptop application, but in a company's where you are, if you're writing you need a system to run at scale. So that's it's called LangGraph platform, I think. So these are the three things they went over the, detail in the conference. So now talking to our goal here is to understand agents design patterns and then think in terms of LangGraph. So that's a topic of the session, right? So and this is just a slide. So according to CEO, I forgot his name. So these are the four ingredients for building the agents. Prompting, and then engineering is the how you scale, how you communicate between agents, and then product is a product, what product you're building, that whether that product that you're building, does it leverage the agents or you're just using for the hype reason. And then machine learning is very important as part of the ingredient, because as you're getting experts, in the beginning it might appear that if you're now then they coined the word called agent engineer, that's behind the shirt. You don't see it here. So the idea is agent engineer is a evolving engineering skill that that person who is building that agentic platform needs to be aware of good prompting, and then good understanding of what product we are building, and then engineering, right, in the sense, right, how the lang chain lang graph, how it works at your SDK level, at the platform level, and then machine learning, right? This is an interesting piece. Some of you may be wondering why we need to know about machine learning at the agents development at the high level. What it turns out is, a lot of this agentic application sooner or later need to be thinking about creating a specialized model. As the agents are getting complex, right? More agents are going to interacting with the different agents. You will start seeing that need of creating your own either LLM, small LLM model, or you need to fine tune some of the embedding model that's used for some search in the tool. So the machine learning still plays a role in building good agents. Okay, so with that said, now let's look at very key concept, right? So I assume all of you, or that's why I asked the question whether you are familiar with any agentic application. The assumption to this session is you have some idea. Some of you might have played with Crew AI, right? At least some level, or at least some small LLM app. With that idea, now we are defining autonomy, right? This is a key concept. When you take an application, LLM application, think about there are three segments. One is start with here, decide what steps are available to take. In other words, your LLM app, even let's not call it as an agent yet. Let's call your LLM app knows what steps are available. Do I need to go to database? Is database is there, or do I need to go to some web search, right? For a given problem. So let's say if you pose a problem, book a ticket, ticket to some place on this date with this condition or criteria, and then less than this price. Let's say you put something like that to your agent, LLM application. So at least it knows what steps to take, right? How it creates, that the question the picture is trying to say. In one case, you can create these steps manually. That's what we used to do traditionally. For the given question I told, you can think about taking four steps manually, and then out of what steps are available, right? I can go to for example southwest, or I can go to that site. So those are the steps available. Then you decide which steps to take for that your question. Then you check if then else conditions in the code. So you see that logo here, if you see the face, what this is saying, um, in one scenario it's completely human driven. We used to code like this. The example I mentioned, book a ticket, flight ticket with some criteria. You can do it in simple Python code, right, without any LLM. But you do a lot of, check the, you may use some NLP to understand the intent programmatically, and then you may have predefined steps, predefined URLs. You can do everything in the code. That is called, you can call no autonomy. Here it's a zero autonomy for your code. Now you can little bit improve, this is a level. You can use LLM for simple things, for just calling that LLM for something, either to format the report you generated. That is a level two type of LLM. you may, sorry, level 2 type of autonomy. For some output, formalizing, you're calling the LLM. That is the second level. Third level, you are saying multiple steps. You might use the LLM for going one for finding out some information, right, about how many flights are available today. I mean, actually, that will be considered as a tools, but think about some multi-step LLM calls. One for outputting the report, other one for some making some judgment. So all it's saying in the level three, you're using a chain, multiple steps to the LLM. That's one level of autonomy. Here, you still see that human faces are there. A lot of code is there. A lot of human made decisions in the code is there. That's a level three. Level four, again, what we call a router. That's another pattern we'll be talking. You make a decision in the you use the LLM to reason and then make some decision. You will tell LLM, given this criteria, tell me this is where the tools will be function tooling, function call, all things came aligned with this router in the level four. Then LLM makes some choice and then tell you this tool to be used, and then you call the tool to get the output. So that's another level of autonomy, right? Even in this scenario, in this scenario, we are letting the LLM to decide, right, what steps to take, which steps to take. That's one level. As you make further execution, then now as you move in the level, now we are trying to call this level 5 as a agent. Here, again, this is a definition, set forth by Anthropic, but I like this diagram. As you say that in a level 5, you are using the LangGraph, to, sometimes in the workflow, in the patterns, there will be a cyclic in the nature. We will talk about what is cycle means. In other words, the decision you are making has, some influence on the previous state, and then things like that might happen in your code. So that we are letting the LLM to decide, or the state machines to decide. So that is or in this case, the lang graph is going to facilitate to decide, to manage the cycles. That is fine. Finally, autonomous. That means very little decisions you are making in your code. You are, for planning, you are using LLM. For reasoning, you are using LLM, and then perhaps you may use LLM to identify the tools to be used for a given situation in that flow, and then you are using LLM for output. So essentially, your code relies on LLM for everything. That's kind of the way I see it. That's autonomous, fully autonomous. Okay, more autonomy increases complexity in the deployment and maintenance. Selecting the right agentic level architecture ensures. So I think that now the question to us is, okay, given you need to develop an application, right? Would you directly go to fully autonomous, or would you stay in one, two, three, or four, five? Who is going to decide? So that's up to you to decide, right? Based on your objective of the project, and then customers, and then use case, and how much also and how reliability you need to have, right, consistency, and then latency, all those consideration you are going to decide one of this level. But aware that if you are going to autonomous, this level involves a lot of tracing, understanding how decisions are made by LLM, whether it's consistently making, whether you need to fine tune. Even the LLM sometimes need to be fine tuned to make your use case fully autonomous, which without that, LLM reasoning might fail or might behave differently in unknown situations, because LLM at the end of the day is a stochastic machine, right? So all those things knows that. So it's good to. So the question here is, when somebody says I have an agentic application in my company, or this is my agent, you can ask instead of simply saying what's agentic application, right? What level according to this? So this gives that idea to visualize what's a true agentic components behind that application. All right, when to use and not to use, right? I mean, this comes to our, before we go to the design pattern. just because you know the agents are there, frameworks are there, so we don't want to design all the solutions with agents. So right, so when you want to define an agentic solution, the like any other system design, first solve simple things properly, right? And then don't build complex system to start with, experiment and understand, and then just keep iterating and then improve this. That's a general design practice in any designing the very complex system. And by the way, agentic system, though it appears, we always say that, right? I mean, Asif used to say, and even in industry people used to say, developing agentic or RAG based app is pretty easy, right? And then as you move towards production, you're going to be facing a lot of problems. That is more and more true if it's fully autonomous. Yeah. So developing, visualizing autonomous is easy, but running it in production, making sure it works is very hard. So hence, you start from the level that you can handle, and then keep moving up in the chain based on the need. All right, so that's sort of the thing about that. All right, now we are getting into. Let me pause here, moving to the before next section. Any questions anyone has? Let me take a look at the chat. Any questions are there? All right, yeah, Mohammed was saying that. Okay, thank you. So yeah, thank you. Yes, Mohammed, you're right. All right. Yeah, there will be some code I will be showing, but not a lot because a lot of these are happening in the course. But I will show some of the course means the actual course that we do. But I will show some course, and then I'll point out to you, a lot of materials. So design patterns, right? So the reason I want to bring in this design pattern, this is a book some of us are familiar. This is one of the first software. Yeah, somebody is trying to ask some question.
Yeah, hi Krishnan. I had
Yeah.
a question.
Yeah.
It's from one of the earliest slides that you had. So you mentioned from Andrew, he was recommending to use an eval framework. So it's just a logical framework, right? You develop, and you iterate, and throw things that doesn't work and come up with something that works the next time. It's not something like tooling the tool or.
No, no, no. He mentioned slightly in different contexts. So
Uh-huh.
that, yeah, correct. But yeah, it is what he was trying to say. Evaluation in this application has multiple phases. If you think about the RAG application, initially given the query, right, we go and get some context. The way we get the context is from vector DB, right? At that point, now you need to make sure, right, the context you are getting is accurate, accuracy is high, precision is high, and all those four or five machine learning, about the quality of the data, right? If you think about past false positive and true positives, right, for any given question, these are the parameters, evaluation parameters, whether it's writing the right answer or it has a wrong answer. So there are a set of parameters called evaluation parameters. So we need to ensure that that is measured for during the context we are getting, as well as when the when we use LLM for, initially we use LLM for only output, right, formatting, things like that in the last year. But now we are using LLM for reasoning. So how do you know? So there are the LLMs are reasoning properly, right? You need to evaluate, outside your end user application and all. As a system engineer, how do you ensure that your LLMs, as I said, three areas. One, getting the context, and in the new world of AI, in our reasoning and planning and steps, we are using LLM. How do you know they are doing it properly? And third, in the response you generate and then output, right? So these three areas, you need to have a proper evaluation, right? That's what he was mentioning. You That is an important piece of agentic development. That's the context of that. And then there are frameworks available, right? If you think about that, there are frameworks like Arise and then Ragas. So there are so many industry frameworks are trying to help you to embed these evaluation metrics in the code.
Got
Is
it.
it? Yeah,
Yeah, got it. Thank you. So
sure.
what he meant was basically to evaluate your LLM
Correct.
using scoring such as accuracy, precision, recall, and use that in your development for improving your the model or your LLM
Correct.
agents. I think that okay. Got it. Cool. Thank you.
Yep. Thank you. So design patterns, I was saying, the reason I want to bring in the design pattern, is to, we all now start thinking about design pattern, right? I mean, at least like every field has a design pattern. This is one of the patterns that we are familiar in software development. There is a creational aspect of, this is not about agents, but this is about how you create an object in the programming world. And so there is a creational aspect of that, there is a structural aspect of that, there is a behavioral aspect of that. Don't read too much into that, but aware that these concepts will be, you can visualize your agents, how it's going to be designing the agents. The agents, we are going to define what is agents in the next slide, but agents have some properties, right? And then how those properties should be designed, and how these can be seen, agents can be seen structurally, and then how it is seen behaviorally. All those things going to be applied, though not directly, but the similar concept will be coming in the patterns. Okay, so we don't need to go into this detail about that. Okay, so now first thing, before we start thinking about agentic pattern, I kind of assume some of you already familiar with what is RAG. So this session is not about RAG, right? Basic LLM app. So this is you can consider this a basic LLM app. What you're seeing in this diagram is think like there is an input coming. There is I put all agent LLM app together, but imagine this is just a simple LLM app. What is that simple LLM app is doing? It's basically retrieve some context, and then it may or may not use tools. If you go back to 6 months back or 8 months back, nobody was in tools. A tool came later, but imagine it used some tools for some transformation or something, right? And then it is here I have memory. Some LLM application we built long term memory, and then finally uses, I think one arrow is missing. It uses the LLM for some understanding the language and then outputting the language and then out. So these are traditional very simple blocks. It's called basic architecture, or you can call basic blocks. Nothing special about that. This is a starting point, right? And let's think about, we are going to add more complex into this, but let's say what is tool? Then we need to make sure we understand tool properly. Tool, now we have, it used to be that, the function, we call the LLM to decide, hey, I have three tools. For my question, which tool should I use, right? And the function, and then the LLM will tell you, for this step, use this tool. And then we used to then use that function calling approach in the code. Later then we have MCP based tools. But what is a tool? LLMs are very powerful, but they can't do anything on their own. To accomplish more, they are often provided with tools to interact, right? So this is typical example. You would see that, right? If LLM needs to know some data from your enterprise data, then what, based, as you're talking to the LLM, your code is talking to the LLM, it might say that, I need to get some information. Here is a tool you use to get the information back to the, your LLM app. So then LLM app will then call the tool and then get the results and send it to LLM for more processing. So this is architecture, already there. But I just want to say that the tool is very important part of the agents. So when you go back to the agents definition, agents will have some objective, it will have some environment, right? And it will have some what they call, not tools, not sense. What is the other one? I forgot that. Uh, and then it uses the tools, right, to achieve or change the environment, right, as it goes through that agent's execution loop. So that's a basic definition of tool. Now This is where our core part of today's call. This is how we are going to start seeing patterns in agents. One is the basic pattern, the one that I showed, and then other one is a routing pattern, React pattern is the most important one for all of us to understand. And then continuation and reflection pattern is, we'll go into that, planning and execution pattern. So these are all the patterns we are going to go a little bit more detail, talk more detail. So let's talk about basic pattern. So some of the slides I haven't filled up, but I'm going to talk over it, right? I mean, as I get time, we will start filling up a little bit pros and cons, and what we'll discuss, in this call about the pros and cons. So why? Okay, first of all, I hope we all agree that understand that why do we need to think in terms of pattern? This gives you a common language, first of all, between developers, and then second of all, given a problem, you can start thinking in terms of solution in this pattern, right? And then as we understand pros and cons of the each pattern, that gives more power for us to visualize the right solution. So there's a lot of benefits in standardizing our thought process into patterns. So basic pattern is very simple. It has one, I think I had to communicate what Snowd means, but imagine that it has one LLM app and then few tools. So the node is a concept used in LangGraph, and I copied that statement here. But imagine remove that node from in your mind right now. So it has one LLM agent and few tools, and then there is a control flow. Very, very basic pattern, right? This is what most of us, writing simple chatbot kind of application might do that. The way you can, you look at the pattern here, prompt, and then tool selection, and then tool execution. This tool selection, I did not put LLM. You can imagine you can also put LLM, and the output is coming from LLM response. Very simple RAG. I don't even call this is an agent yet, but remember in our level, this is in the level one, in the level 1 to 5 or 1 to 7, I think. It's in the level one. Reflection pattern. Now, what is that, right? So this is interesting. Some of you might have done it, or definitely you would have heard about that. What we want is when we call the LLM for anything, for sometimes reasoning or sometimes output generation, right, or making some extraction decision. All you are doing is, you're using a evaluator, self evaluator. This evolve is different from the evolve, that we talked before. So this is one is about evaluating your LLM action response is correct or within the acceptance range. It's like someone verifier, right? If you want to verify some critical documents, we'll give it to two people just to make sure we don't do mistakes. In a similar way, here the reflection pattern suggests, right? For every, you can say in your company, you want accuracy to be very high, right? You don't want any mistakes in anything. So you want to double check, right? That the double check is the self evaluator. So that's a pattern, then it improves the correctness and reduce hallucinations. What's a benefit? That's a benefit, you get it. All right. Pros and cons. I think, yeah, pros, that's the one I said. What is the cons? Suppose, obviously, you can easily visualize, right? It takes another call, and sometimes it's not about another call. The self evaluator is, it might use some other LLM, local LLM, or not powerful LLM. So there is a latency in the response, right? Your response will be delayed. Those are all cons. So the way you have to think, right, in when you're applying this design pattern to in your application, if you are sure that you're handling the correctness and well before it goes to LLM, you probably don't need this. So that's a decision you need to decide as a architect, right? What's your application needs of the correctness? Is it already handled much at the higher level? Those things will determine to use this pattern in your blocks. Reason and act. This is very, very popular one. Most of us, I would say, in any company, when they start the agents development, they will start with the reason and act. Of course, basic one we talked is more like a RAG. So now this is more like agents. This is a starting point of a good agent. This mimics how humans often think, when we want to solve a problem by thinking through steps and then checking the each steps and then decide the next steps. Yeah, you can come up with your own example. Think about even booking a ticket, right? How you are thinking about it, in your mind. You first think about looking at different websites, right, for a particular date, right, and then I mean, I do go to Google, Google flight search. Then I go to Southwest and then look for fare deals. Then I may select different in a nearby in a sort of airports and decide all those kind of things. Whatever you're planning that in your mind is what you want to actually plan. So this is what exactly you are seeing in today when you go to the Foro or any other, any other cloud. So you see that thinking. That thinking is much more sophisticated. That comes under planning and all. But this is a starting point of that through the steps think. So this is the important framework. Agent does not just respond directly. It thinks about the problem, decides on action to take, observe the results of that action, and then uses that observation to inform the next action. So, this is the basic pattern. Let's see it in the diagram. I mean, if you visualize in diagram, you have a starting. This is what we are going to go as we are slowly getting into the LangGraph definition. In the LangGraph, you will you will see why LangGraph is so powerful. The reason it is powerful is when we start thinking about these. Right now, you are starting thinking as a graph. Now you are starting thinking your RAG application or your agent application in terms of some kind of a node starting. You have steps, and then each steps you execute, you look at the results. Based on the results, go back to the previous steps. That one we need to translate that mind into some kind of a visual node. So here you are starting the session, you can consider, right, you can think like that, and then it goes to assistant, say, node, and then it uses the tools, and then it uses the tools many times. That's why the circle is there. And consider this is a main program, and then though its LLM is not shown here, it uses the either LLM or its own come up with the steps, and for each steps it calls the tools, and then based on the observation of the tool's results, it again calls the tool until the exit condition or end condition is met. So that is called react pattern. Okay, so this is a continuous loop pattern. Until the loop terminates, you keep observing, calling, and checking. So you can use this idea for building many type of your LLM application. Booking the tickets, and then solving a problem, right? Bug fixes, and then so now that is up to your imagination. So for your given use case, is that design or is the design pattern is sufficient? Is the one you need to decide. But there are pros and cons with this approach compared to other approaches. More granular approaches are coming next. So what is the pros and cons? We'll talk about this. But before that, let's take an example. If some of you are not familiar with this React pattern, here is an example, right? An agent is asking the capital of the country with the most Nobel Prize winners. Let's say that question is asked. What do you do? If you're a human, right? Of course, you go to Google and then you'll say the same thing. But let's say Google is not there. But you will do is first, what's the first capital of the country which has the most Nobel Prize winner, right? For that, right, you need to find what is that country which has the most Nobel Prize. That's the first thing I want to know, and then translate into an action. The action is nothing but calling a tool. Then the tool gets you the answer. Then now I know the country, right? And then for that country, what is the capital? That's a thought two, and then that comes United States, and then there is a end condition. So then the thought says I have found this. Then what can you do next? Then the system will say you're done with that and exit and come back. So this is an example of thought and action, right? So So what it looks good, but what is the problem with this? There are pros and cons of this approach. One of the one of the reason it might, when you use this approach to solve complex problem, here it is at least two steps, right? Imagine you have 10 steps, all right? You have even 50 steps. When there are more steps and thoughts and then more actions coming for your use case, here this might start breaking. Okay, that is the knowledge we are gaining. As there are more thoughts, there are more tools. As it is becoming more, there are error conditions, right? There are corner cases, and then and then if there are tools with very minimal differences, and then the steps that decides which tool to use might make a wrong decision. So there are more chances for error, and then more chances for getting this into loop. So what we are saying is, as part of the, improving our design, so the now most likely, there are challenges it goes into the loop. It will never come out of the loop, and it will give wrong answer. So it just keeps on waiting until the final answer. It will try all kind of combinations. All these things start happening. I'm sure many of us who have developed this agentic application who use this, they might have seen in real time. It might work in the development for simple use cases, but when they take it to the production, based on the questions, thought is it will go through multiple thoughts, and then it start failing. So it's a very, 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 very common scenario happen to many agents development. How do we then solve it? So if you then okay, before we say how to solve that, put it in the pattern table. In the structure is the agent reasons step by step and interleaves the tool use with a natural language thought. I mean, what mainly it says that for every action, it checks the results and then decides the next action. That's what, based on the thought, right? Decides the next thought. That's what it means. All right, so the pattern is like this: a thought. A thought can be formed using LLM. I know there is a prompt here which is missing. So then the prompt, then there is a thought, and then we go through the tools and observe that from the tools. You can either use LLM or you can inspect the output from the tool yourself. If it's very simple results like numerical, you don't need LLM to inspect. If it's more more descriptive, you might use LLM for understanding the results, or you can have your own machine learning model to inspect. But you repeat that until final answer is coming. So this is a little bit of a you know engineer version of the pattern, not in the UI way, but in a cryptic way. And then pros and cons, as you see, uh, of course, it has an answer reasoning and problem solving, because we are first breaking the task into thoughts. Thoughts then help you to decide the actions. So it's always good to solve problem, but not too complex problem. So again, I was saying the thoughts, number of thoughts and number of tools will as it increases, it will increase the likelihood of loops and other things. Yeah, the cons is infinite loops and stuck states, increased latency and cost, complexity in development debugging, over reliance on LLM for planning. So these are all the cons of this pattern, right? Let's go to the next one. Okay, so here is an example. This is an example of infinite loop. So if somebody wonder what the loop means, for example, because you're at the end of the day in the real company, right? You'll be using tools somebody wrote or somebody developed, and then you are writing an agent, and then the agent is saying in this example, the question is finding an available meeting room in building A for tomorrow at 10 a.m. that seats at 10 people, at least 10 people. Then your agent application, it says I need to find meeting rooms. I should check the room booking systems. Then it's making a action through the tool. It's calling some query booking system, and then it's passing the time 10 a.m. right? But what happens is, in this example, imagine that there was actually room at 10 a.m. but somehow, okay, somehow the action, the tool is not sending. But then the LLM app that you wrote is observing that no rooms found for 10 a.m. But apparently it seems like which is completely broken. The room is available, but your agent is not able to figure it out. And then you see that again the agent is going to try it out. It's a part of the retry mechanism. So now we are talking about system engineering. This is a crucial, again, when I was saying, right, developing for the for the learning purpose or even for POC purpose is different from production purpose. Here, when it fails, somebody implemented a good retry mechanism, right, but still it started failing. Nobody knows until, and then it goes into the loop, right? Keep wondering going on until you implement any hard check, maximum retry, or exit on this, something like that you need to implement to come out of that. But in this scenario, what really happened is the tool is expecting not AM. Seems like, there's some example. It was not expecting AM. So because of the formatting issue, it keeps on failing. All right. So that is the React framework. Planning and execution. It's another pattern. So this is the pattern. It's looks similar to React, but it is also slightly different from React. In the React case, as I was saying, right, as the number of steps and thoughts keep going, there is a problem, right? So the planning involves defining series of tasks that need to be completed to reach the final goal. So the idea is to divide and conquer. Given a complex problem, now you can solve the higher level problems, right, by solving smaller level problems. It's a kind of recursion. Then smaller level problems can be solved recursively. So this is a much sophisticated version of the React, but it is a slightly in a different design. So this is probably the planning and then execution pattern. Many agentic platforms like Perplexity and other guys will be using this kind of patterns. Uh, right. Let me come out in this loop. Okay. Now I'm going to show an example of the planning and execution pattern, but let me. I think I switched the slide. The React pattern was having the handling the was a loop, right? How do we handle the loop? Obviously, we need to make sure all the tools and then agents calling the tools have a proper expectation, right? Proper communication, and then proper in terms of formatting, stuff like that, and then have a retry mechanisms, and then things like that, exponential back off, maximum retries, and replanning. These are all the key concept. During the failure situation, you need to be handling it. So this is how you. This is a best practice like any other software discipline, but at least we know this is applicable to the React pattern. All right. Let me pause here. Any questions before I move? Okay. All right. So, okay, workflow pattern. As we talked about, workflow and agents. See, this is one of the most interesting and important thing happening in the industry, right? Um, how much, how much autonomy in making the reasoning we should give it to LLM versus your predefined workflow path. So, if your application uh, definitely needs deterministic path, and very rarely enough for LLM is needed for output generation or summarization for multi-model, and then some places you need LLM for understanding the input coming, right, and then getting the semantic. Other than that, in between you have a deterministic workflow, and then your company already has so many tools. Then what you are looking at is a workflow pattern, right? You're not looking at multi-agent, you're not looking at the React pattern, or you're not looking at the planning and execution pattern. So what you're essentially is taking the existing workflow, only putting the starting and ending, right, using the LLM for managing the input output multi-model. The rest of the in between is just a workflow, just simple RPA workflow. If you have that, and now the question is, now that we are all moving to agentic platform, if you notice in many companies and many projects, they all wanting to convert, obviously, right, RPA workflow. Yeah, let's move to agentic workflow, right? It has a lot of benefits. So all kind of things are going on. Sometimes it's over engineering. But at least we know, what we are trying to do is, when that kind of project's coming to us, it's basically in between is a deterministic workflow is what needed, with the input and output, and then few other things where LLM is helpful. So that's how I see it. So that scenario, you can still use the agentic platform, either LangGraph or Crew AI, to still build the deterministic workflow. So today, when I was just waiting, I just went to Crew AI, right? I just saw. I was thinking about that Crew AI conference, not conference, Crew AI meeting for deterministic workflow. So today they announced some course or something like that. You can see that. Okay. Okay. So, I will send you that later. What I'm trying to say, Crew AI today send me an email to say that, building the deterministic workflow with the Crew AI. Why did they say that? Basically they wanted to see a lot of these automation projects going on can be redeveloped with some benefits of agents, but still maintain the deterministic nature of business, right? Well, business process. So that combination is a powerful one. That's where a lot of um, thinking going on. How do we bring in the LLMs and then agents and then deterministic aspect of business workflow in the mix? So that is a part of the workflow pattern. Now comes to multi-agent. Okay, so far we are talking about single agent. So this is the very important concept. The single agent inside there is a workflow, or inside React, or inside it could be a planner and then execution loop. So these are all within the agent is happening, right? So far we are talking, and but what about the multi-agent? Now, why do we need multi-agent, right? It is very similar to, when I was talking about React has some limitations. As the number of tools, as the number of thoughts goes higher, it struggles in infinite loop. Similarly, in agent, when you put too much responsibility into the agent, then it's going to make poor decision. So, in other words, now we start thinking about the responsibility, right? Minimize and focus in each agent. Extend the same concept. The React is limited, then we go to the next level. Similarly, agent at some point is going to be get messy. So why not we think, in multiple agents? One for managing the complexity, and second, complexity in terms of the code and stuff like that. Second, you can think about reusing the agents workflow. Some agents have some partial workflow needed from some other agents. So reusability, composability, and then and the different vendors and different platforms are working together. So this is where agents are coming, multi agents are coming. Initially you will see multi agents in the same technology, LangGraph multi agents working together. But you will also see multi agents between, say, LangGraph and Crew AI. That's where the momentum like A2A came in the Google's proposal of A2A, intra agents communication. Then extending that, agents will be running everywhere, right? You need a directory, you need identity, and then you things like Cisco agency protocol came, and MIT now is thinking about Internet of Agents. You can visualize them in much more next level. But that is beyond the scope of today's discussion. But from multi-agent pattern point of view, the goal is that we'll have different responsibility. And why we need it is, if you try to build everything in a single agent, it makes a poor decision, and it might not work the way you want. So that's a way I see it in the design pattern of context. All right. Now multi-agents appears, as a single thought for us, but as you go, there are many flavors in the multi-agent. This is now we are talking the highest level of agentic design, right? We started from simple, then went to React, and then came to Planner, and then workflow, then agent. And within the multi-agent, you have many flavors. This is something we need to be aware. It's in a simple word you can imagine, right? When you have many agents, how they are going to interact with each other. You can also think like in human, the way we work in a society. We interact with others, sometimes peer to peer. We sometimes interact with our supervisor or some leader, right? And then sometimes we do hierarchical interaction. We tell to our subordinate, then subordinate tells their subordinate. So it's kind of the same thing. You can visualize the same human interaction patterns, and then apply that here in multi-agent. Now, each one, this is what we need to experiment and say. You can say when is network approach is better, peer to peer is better, or when is supervisory approach is better, when is hierarchical approach is better. This level of design, I mean, obviously I've not gone to that level. I'm still experimenting with supervisor now, right now. I haven't gone to hierarchical and then custom multi-agent, but I think this is where the next level of design patterns are going to coming in. Okay, you can just read over that. All right, so let's move on. Okay, now, so see, the way I wanted to shape up this session is that first to explain agents, and then some concept behind the design patterns, and then up to now it is more irrespective of the framework, right? But these are the design patterns concept. And then now when we want to apply the to one of the framework, which is the LangGraph is the framework for now I have chosen, right? So, but these are all the other frameworks that you're familiar. I mean, you at least some of you listed in the initial poll. What is LangGraph, right? So LangGraph is why every framework is of course has some pros and cons. CrewA excel in something which is called collaborative aspect of the agents, multi agents. That's where CrewA is excel. LangGraph, is powerful, but powerful, but it provides a low level instrumentation. It does not provide a higher level instrumentation like CrewA. So it has both pros and cons, right? In LangGraph, you need to stitch together. For example, first of all, in LangGraph, you have two levels. One is within the agents, what are the things you need to do, create, and across the agents, how do you define communication. Two different aspect in LangGraph. Versus in CrewA, it's slightly different. You just start thinking from agents first, and then you don't need to think in terms of to start with a graph or flow, but they also have a flow. But at least the starting thinking is your agent, start thinking in agents and start thinking roles and responsibility, and then define flow wherever it's needed between the agents. LangGraph completely ground up. You define graph in which you define the agent's nodes, a single agent's nodes, single agent's workflow, and then later you can then stitch together multiple agents. So that's the approach LangGraph chosen. All right. So what is, only three things we need to be knowing in LangGraph. Of course, what is a graph? What's a node? What's a edge? Of course, graph coming from computer science background, you can easily visualize, right? Graph can be cyclic or acyclic. It is of course different from tree, right? And then a graph has nodes, and then each node may be connected to other node by edge. So now the thing is that when we start thinking about our LLM application or LLM agent, previously we never used to think in terms of graph, right? We used to think in terms of maybe workflow. Maybe LLM app is calling after query transformation or query parsing, it calls the LLM and then we do the response handling. So we kind of viewing that as in a block, sequential block, maybe a little bit parallel block. But now in agentic world, we need to think differently. So we start thinking an agent has graph, and then it has some starting state, and then it has a ending state, ending criteria, and then in between there are nodes. So that's the starting thinking. All right, let me check the time. Oh wow, 8:22. So it'll take 15 minutes and then we'll stop. A graph is the entire workflow or program, right? That we understand. It has nodes. We'll stop with that. A node is very important. A node encapsulates LLM prompts, API calls, and function execution. I mean, I'll show you an example of that. Uh, right? And then, a graph consists of multiple nodes. An edge is, connecting the nodes, right? I mean, it appears so much description, but let's take an example quickly. Example will make it easy. So this is the crux of the LangGraph, right? If you understand, then pretty much, I think 70% is understood. So what you do in basic pattern, now remember we are going to apply this in basic pattern and routing pattern, things like that. We'll keep using this in pattern. But today's call, let's simply understand the basic pattern, how we translated a simple LLM app into a basic, agentic pattern. So what is two things you want to start from bottom to make it easy. In this case, remember I told you, right? Agentic application is kind of a workflow, right? Whether it's a React flow, actually I should call it as a flow, not workflow. Whether it's a React flow or is it a planning and execution flow or is it an agentic flow or a normal workflow, it could be one of those four patterns. In this case, let's consider as a flow. It's a very basic flow. So I initialize a state graph. That's what they call in a line graph, and then I attach the node called model. So model is the node, which is going to call the LLM and then get some response, right? That is a node. So I create a node called model, but then I would have in any flow in LangGraph will have a start and end. The starting is the model, and then in this case the ending is also the model. So since it's a very simplest basic pattern for showing the example, so what you have done here is a basic agent. It looks like a RAG, simple RAG or simple LLM app. Yeah, it's not RAG, it's a simple LLM app. It's simply when you start it, it's going to be calling the model node and getting the answer. So this is a uh, so I don't have the example of calling, but this is how you create the graph node in the lang graph. All right. So after that, what you're going to do, the code does not have it. Then we'll call, LLM dot call, and which gives some input message. Then it's going to circulate into model node and get it. But the point here is I'm going to say you're created a flow, lang graph flow. So now you can expand this concept into, you can create your own, flow. You can create your own workflow in React. This is not a React act. It's a simple call. So next one is routing. So in the routing is important part of the decision making. It's used in both the React and both the planning and execution pattern. This is to tell you that a router will decide based on the state, based on the action. So that's an example of that. Without going into detail, all I'm trying to show you the route pattern here. Yeah, I didn't. I think we went out of time. Does this can automatically implement? Yes. Yeah. Okay. What is the kind of tool or agent you are and support vector? Okay, let me ask you, because we are running out of time. I need to finish it. Then what we can do, I have only few slides, but quickly to answer you, you may need to go. What's the kind of tool or agent you are guys are building a support vector? Give some concrete. Okay, all right. And does it automatically? Okay, so the answer is in support vector. Support vector is one of them. One part of them is training organization. We do have in the course called agents. It's a 16-week course. We build a lot of complex agents, right? And using Crew AA, and then of course LangGraph is being used now. And I was telling you that we go into the patterns that we are talking about, right? The agentic pattern, workflow pattern. And then as part of that, we also train a model. And then model will be used as part of the MCP tool to demonstrate that future agents need tools. The tools need to be our home trained. Existing LLMs will not be satisfied, will not be workable. So you need to retrain, fine tune some of your model, and then expose tools to utilize a new model. Then tools get exposed via MCP to all these agents. So we do go through those kind of projects and POC extensively in the course. But in today's call, it is not. This call is about just giving you some perspective of the patterns. Okay, quickly to finish the two more slides. Workflow pattern and multi-agent pattern. So what I was trying to, this is from the one of the examples from the support vector. So workflow pattern is, as I was saying, you basically have a deterministic nodes. Now I'm calling as a nodes because that's why we call in LangGraph. You have a deterministic. You don't make a lot of LLM for reasoning. You don't make a lot of LLM calls for processing the results. Uh, you might make, but your next call or next thought, next action is pretty deterministic. So that's a workflow pattern. And the multi-agent pattern, I know these diagrams are not very clear. It's a cut and paste from some place. But as you can see in the multi-agent pattern, there is a concept called supervisor. As I was saying, network supervisor and then hierarchical, all kind of combinations play a role in the multi-agent. But the theme behind that multi-agent, thinking in multi-agent comes from the angle. One, it depends upon how your organization boundaries are defined, because those things will influence the multi-agent architecture in your company, right? Domains used to become APIs. Now it will become agents. Then pretty soon you want to interact with other domain, other departments agents together to make true multi-agent. So many factors will influence a multi-agent, not only your internal design, your peers and organizational boundaries. Things like that is going to be a factor in the multi-agent pattern. But this is how multi-agent works. Now, it is very complex in runtime in production. Just take this multi-agent. Imagine this is one of the agents flow, right? You're giving some query to this start node. Imagine in your organization, thousands of queries are coming. So imagine your platform, which is running this agent, right, needs to be for supporting such scalable, agents runtime. These are graph execution engine, right? These are acyclic graph, multi-processor or multi-threaded execution engine. So all these things need to be work at scale. And then correspondingly your chatbot has to know, since it's acyclic, since it is information coming from anywhere, it could be sometimes coming from other organizations, agents in the future. Imagine future agent communication happening, and then coming, and in your chatbot you need to know who is sending. It needs some other action, you need to give some other input. So all those kind of complexities in a true multi-agent system interacting with the human in loop is still, in my opinion, long way to go for enterprises. These kind of things may have happened in Perplexity or other large true cloud level, but at the enterprise level, it just start happening. We are still in thinking stage. Now, with that said, in order to know more about that, you should go to, now I'm switching that. I'm just stepping here and then taking you to this YouTube, and then that's where this is going to come in. Go to the playlist and then go to interrupt.
So in terms of what
Okay, and then start seeing this just happened a month back. Start seeing how
I'm really excited.
start looking into I have looked into most of the videos. Start looking into how each company is building the agents, right? One of them is Cisco. That's where I come from. But unfortunately, I cannot go detail on that. Though I have slides to ready, but we ran out of time. But I ask you to go here. So this is a state of the art. This is pretty much the state of the art in the Lang chain, Lang graph, how companies are building a scalable, trying to build scalable agentic platform. So with that, I'm going to stop. But please do go through. As part of this course, or not course, sorry, part of the session. My goal is to show you. This is a very very interesting information to build this, at least to know what companies are doing to build the large scale agentic platform. With that, I'm going to go to the last slide. I'll end here. Okay, so what did we do? Yeah, we talked about design patterns. The goal of today's topic is to introduce to the design patterns, and then thinking about implementing agentic application in a simplest to complex approach. For that, you need to be aware of the design pattern, and then this design pattern will help you to communicate with other peers easily. I just started the long graph. I just ran out of time, and please look at the interrupt in the LangGraph conference. That gives you all the latest trend in this agentic platform and design. So with that, I'm going to end. And as part of this, please check out the support vectors page. We go through all these things much more detail in the agents class. All right. Thank you, guys. Thank you. Nice talking to you.